Thank you very much for the kind introduction. Today's talk is about a dose monitoring software in conventional X-ray imaging initial experiences. As you all know, dose management is an important part of quality assurance in radiology and is already proven for computed tomography and fluoroscopically guided intervention. This can be accomplished with a dose monitoring software. By the end of this talk, I hopefully will have convinced you that this is also of benefit for conventional X-ray imaging. In comparison to the aforementioned two modalities, namely computed tomography and fluoroscopically guided intervention, high dose values are not that of a problem for conventional X-ray imaging. However, here we are faced with large data volumes. The purpose of the present study therefore was to share first experiences gained after the implementation of a dose monitoring software in conventional X-ray imaging. Let's move over to the materials and methods. The study was performed at 4 units, namely 2 fixed and 2 mobile units, all equipped with digital flat panel detectors. The detectors automatically provided the camera area product, CAP, as well as the intense surface air camera, ESAC, as dose values. These were then analyzed with the commercially available dose monitoring software. The study was split in 2 periods, lasting 5 months each. In period 1, the patient dose monitoring software just ran in the background and radiographers were not able to assess dose data. At the end of period 1, an internal dose audit was performed, and during this internal dose audit, 2 tasks were done, namely a review of the technical settings, and based on this review, the exposure indicator value was doubled and was then equivalent to a sensitivity class of 800 as known from the former film screen combinations. Moreover, the current time product and tube voltages were adapted accordingly. And secondly, radiographers underwent a 1-day training in radiation protection, during which they were taught in 4 things. First, reasonable collimation, second, proper grid, third, accurate patient positioning, and fourth, use of protected devices if thought necessary. Thereafter, period 2 started, during which real-time monitoring of patient dose with the dose monitoring software was performed. This meant that radiographers went to the computer and read dose data after completion of each examination. They were asked to check whether there was a dose excess or not and to assess possible reasons for this dose excess. Analysis was performed either for single radiography, which is 1 projection, or study, which is 2 or more projections. Before analysis was started, data cleaning was performed and all examinations were excluded which had a duplicate or invalid accession number or with an erroneous protocol name. Data was summarized in box plot diagrams. Let's go over to the results. In total, during period 1, we had almost 14,000 radiographies and almost 8,500 studies. Compared to that, in period 2, we had a little bit more than 16,000 radiographies and 10,500 studies. As these pie charts clearly show, there was a comparable number in the relative distribution of the type of examinations performed, and because of that, reliable dose data comparison was possible. Let's go over to the results, to the dose data. In period 1, we had the mean dose values for the CAP for the radiographies of 0.5 to 8 Gray centimeter square and for the studies of 0.66 to Gray centimeter square. In period 2, for the radiographies, 1 projection, we had a mean CAP of 0.386 Gray centimeter square, and this is equivalent to a decrease of 25%, with a decrease ranging between 1 and 52%, and this decrease was significant in 8 of 13 types of radiographies. For the EDEC, the other dose value, we had a mean reduction of 24%, ranging between 2 and 53%, and this was significant in 6 of 13 types of radiographies. In the studies, the mean CAP decreased by 7%, ranging between 0.4 and 20%, and this was significant in 6 of 14 types of studies. For the EDEC, the decrease was 5%, ranging between 0.2 to 22%, and this accounted for a significant decrease in 5 of 14 types of studies. Here are 2 examples of box plot diagrams are given at the top for a radiography and at the bottom for some studies. The one at the end of the study name always indicates that this is those data stemming from period 1 and the 2 from period 2 accordingly. As you can see, for the shoulder AP, for the cervical spine and for the lumbar spine AP, there was a significant decrease between period 1 and period 2. And for the studies, this decrease was significant for the knee, for the ankle, as well as for the foot. So concluding, our study showed that the dose monitoring software enables real-time monitoring of patient dose not only in computed tomography and fluoroscopically guided interventions, but also for conventional X-rays. Moreover, we were able to show that the dose monitoring software enables comfortable dose data collection. Our research indicates that the dose monitoring software supports dose reduction efforts, and on the whole, it may increase radiographers' dose awareness. Thank you very much for your attention.